A very good morning to everyone present over here. Society for the Advancement of Agricultural, Horticultural and Allied Sciences SAHAS welcomes you to the second day of training program on precision farming. Today, we'll be engaging with an impressive lineup of presentation by one of our eminent personality who is well versed in the field of precision farming. So let me give up a brief introduction about today's speaker. Dr. Ashok Kumar Meena is basically a plant breeder and a renowned scientist. So being a plant breeder expertise, it is his versatility that got him connected to precision farming. With his passion, he has been associated and been practicing the precision farming with over the years. Having done his BSc in Bikaner and MSc in Hyderabad, he has got his doctoral degree from University of Agricultural Sciences, Dharwad. Having qualified in NET thrice and currently working as an assistant professor and in charge under the All India Coordinated Research Project on Groundnut RAU Durgapura, Jaipur. We are overwhelmed to have with us Dr. Ashok Kumar today, who is an eminent personality. I heartily welcome you to the program, sir. So before we start up the program, let me give up a brief introduction, general instructions. We all know that the general instruction remains the same over the days. And for those who are seeking certification, it is imperative that you all candidates have to attend the lectures and submit the feedback form on precision farming. And throughout the training sessions, if any doubt arise, I encourage all of you people to raise your hand and interact with the speaker during the designated doubt clearing sessions, which will be followed after the presentations. So if you have any kind of doubts, you can raise your queries once the discussion session is being over. So this is the general instructions for today's program. So we all know that precision farming lies at the suite of technological tools that empowers the farmers to take informed actions. It covers a wide range of insights into the soil health, moisture, growth pattern, etc., using remote sensing drones as well as satellites. So precision farming has been a boon to mankind these days. So today in this slide, Dr. Ashok Kumar with his beautiful picturesque presentation will be enlightening us about precision farming, its components, and will be brief about the overview of precision farming. Now, I call upon Dr. Ashok Kumar to start up the session. Over to you, sir.
Thank you so much, Tamanna and Sahas Society for inviting me for this lecture on this online training program of 7 days. What guys you are doing, this is very wonderful training. Actually, this precision farming is very new area of agriculture. And in our country, now we are not at least in the developing country. Almost we are a developed country. And yesterday we show the world what India can do. So now it is a time of precision farming in India also. But some problems associate with the precision farming regarding India. But definitely in coming years we will be there for this precision farming. Okay, then I will start from introduction. What is then means the need of this precision farming, what we are doing in the agronomical practices in our agriculture. In historical agronomical practices and management recommendation, we have been developed for implementation on a field basis. This general result in the uniform application of tillage, fertilizer, sowing, and pest control treatment at a field scale. Farm field, however, display of considerable spatial variation in crop yield at within field scale. Means what we are practicing regular, we are practicing these things. What will happen with that if we will go for regular tillage, that same dose of fertilizer, same date of sowing, and all this pest control, what we are using insecticide, pesticide, same dose, and what we are using. But in farm, if you will see there in some page there is insect effect is there, but in some other page that insect effect is not there. But what we are doing in regular farming, we are having insecticide spray to whole field without seeing the page there is insect or not. That is the problem in our agriculture. Then such uniform treatment of a field ignore the nature and induce continuous variation in soil properties, and maybe result in zone being under and or over treated, giving rise to economic and environmental problems associated with this inefficient use of resource inputs. Means if what will happen, will give regular treatments to our soil, and this our economic, yes, what input we are giving, that is high costly, because if you will go for chemical insecticide, pesticide, that cost is very high. It is not affordable to our farmers regularly, and it is affect not only our economic status but our environmental status. Means what, we are spoiling and polluting the environment tremendously. Means regularly what we are doing, that practices will definitely have harmful effect on our nature and for our environment. The most sustainable substantial of these problems are economically significant yield loss. Yes, regularly if you will go for these treatments, then definitely this yield variation will be there. In some area it is good, but in other area it will be less. In same farmer plot, somewhere we are getting nearly 50 quintal yield of any crop, and in another page we are getting 30 quintal. This is the spatial variation what we are facing on field. Then excessive chemical cost. Yes, definitely that chemical cost is very high in, nowadays, and that private companies, they are charging because they have monopoly in some chemicals. That's why what they are charging. If you go for imidacloprid, then now the cost for 1 liter is 3,000 rupees per liter. Then gaseous release of chemical components. Yes, that what chemical we are using in the field, that is having harmful effect on our health as well as our animal health and our nature, our plants, every, and what our beneficial insect, that will be another problem. Unacceptable long-term retention of chemical components. Yes, the chemical something means some substance of that particular chemical will be retained in our soil, and what crop production we are having, in that also some, in some quantity it is there, when that have this adverse effect on our health, like cancerous causes, many things. A less than optimal crop growing and environment. Means what type of crop is required that particular area, it should be clear, not just randomly we are going to in whole area we are showing the same crop, but it should be variation what is required and what we have to produce. Then this precision farming, yes, this can be a very good thing and very good practice what we can follow, which can save our all thing, means inputs, and it will give good outputs in the case of yield, and it will save our soil, our environment, everything we can save by this precision farming. Precision farming first appeared in 1970s in the United States. As the condition of farmland are quite different in different places, precision farming can be effectively save input, reduce cost, abate after effect to environment. This is what is happening in this precision farming. We can save input, reduce cost, abate the after effect to environment. Yes, definitely we can reduce the environmental effect, means pollution affected, like that. precision part, then what is mean this precision farming? In both of site specific management offered a remedies to many of these concerns. The philosophy with this precision farming is the philosophy involve matching resources, application, and agronomical practices with soil property and crop requirement as the very across a site. Means philosophy what behind the precision farming is that matching the resources application, how much that fertilizer is required for particular land area or for a particular grid, what type of dose is required there, and what seed rate should be there, what means the fertilizer, and what is this insecticide pesticide dose should be there. It will decide accordingly, means according situation it will decide. Means it is you can say it is a sensor based farming. Precision farming approach is required to ensure that the request resource for crop growth are available and crop protection need are met without deficiency or excess at each point in time during growing season. Precision management can be applied based on requirement to field. They please see this specific thing on the requirement to feed at right time, right place, right quantity, right method. Here all things should be accurate and efficiency should be there. On what time fertilizer should be given, at what time sowing should be done, and where should be done, right quantity, how much quantity of fertilizer and insecticide pesticide we have to give, and by right method. That method also is important. You are providing fertilizer or insecticide pesticide, but it is not covering your crop, then what is the mean of that particular spray? That's why right method should be followed. These are some definitions of our precision farming. The word precision farming means exactness or accuracy. Yes. What is the precision? Means what? Exactness, accuracy. Precision farming means the process by which exact or accurate result of farming can be obtained. There are several definitions which are means what? Accuracy should be there and exactness. You just assume in your computer what you are putting for just some application you are putting same thing and it will apply for all. Then this type of accuracy we need, but it is practically that much it is not possible, but on some constraint it is possible. How much we can control and how much we can apply, it is possible there. Precision farming is defined as informational based and technology driven agriculture system which designed to improve agriculture process by precisely monitoring each step to ensure maximum agricultural production with minimal environmental impact. Means what? We have to get the maximum agriculture protection by giving minimum inputs and by minimizing environmental impact. Means side effect on our environment should be reduced or should be minimized. Managing each that another definition is there by John Derry. Managing each crop production input like fertilizer, limestone, herbicide, insecticide, seed, etc. on a site-specific basis to reduce waste, increase profit, maintain the quality of the environment. This definition is given by John D. Precision farming is another definition also is there. Precision farming is defined as information and technology-based agriculture management system to identify, analyze, and managing site soil, spatial, and temporal variability within field for optimal profitability and sustainability and protection of our environment. Means from all definitions what you are getting, one thing is clear. Means you have to give minimum input, you have to get maximum output, and there should be minimum environmental impact. Means you have to manage the thing exactly and with accuracy and with effectiveness. And yes, definitely this effectiveness should be there with efficiency. This is the our other name for this our precision farming. Special variation crop production, GPS based agriculture, site specific and precision agriculture. These are all the different name of our precision farming or precision agriculture. Then what is the objective of our precision farming or precision agriculture? Means for what we are going for this precision agriculture? What should be the main objective of our precision farming? Increase this very first objective in all. If we will go for all agriculture practices in any area, then what will be the first objective? Always for a agronomist, for a plant breeder, for anyone, what is the first objective? The first objective will always be increase production efficiency or increase the production, increase the yield, improved product quality. Yes, nowadays because we are producing self-sufficient food, then we will go for quality. You have to maintain the quality of food, then this precision agriculture will work. More efficient chemical use, yes, definitely. The what chemical we are using, it should be effectively and efficiency it is used, because the chemicals have very harmful effect on human health and our nature also. Energy conservation, yes, definitely we have to save the energy. Soil and groundwater protection, this in coming years and nowadays what we are facing the with our soil health drastically, means drastically affected by our giving this overdose of fertilizer, insecticide, pesticide. We are playing with this human with soil health, and definitely it have very side effects on our soil health and nature also. Then groundwater protection, if you will see in the present scenario, in somewhere we are facing the drought and this water availability is very less. Okay, in rainy season sometimes we get high rain, but maximum means in some area we are facing for drought, because the water conservation of water or better effectively and efficiently use of water is very important in present era that the precision farming is having. Then the need of precision agriculture. What is the need? Why we should go for precision farming? Because that is not a easy task for go for this precision farming, because it's have very scientific knowledge and sensor based technology. It is not now have only agriculture scientists will do. It is required this other space scientists also have their role in this precision farming. That then what is our need to go for precision agriculture? Stagnant yield, depletion of biological resources, means if you will see our soil health, water, natural, all are we are depletion of biological resources. Decreasing per capita land holding. What happening in present time, the land holding per capita is decreasing regularly. It is decreasing. It is processed by, if one family get four son, then their land definitely will divide by four only. Providing adequate nutrition for people. Yes, we'll go for now. If you'll say in the world level, then this malnutrition problem is the biggest problem of our world scenario. Not only for India, it is the problem of whole world. For increased agriculture productivity of the food crop, yes, definitely we have to go for high production, reducing persisting poverty and hunger. Yes, it is should be, and it is our ultimate aim. Persisting poverty and hunger should be reduced. Being an agriculture scientist, I'm requesting all of you, you just put your all effort for this to reduce poverty and hunger by this precision farming or by your support. Then basic step for precision farming: assessing variation in field, managing variation and evaluation. First thing is what type of variation is there in our field. Means if what type of nature is there in our farm, what type soil is there. Then basic step for precision farming: assessing variation in field. Means what type of variation is there in the field. It should be known by that particular farmer or that particular scientist. To manage that variation, means what type of variation is there, means for soil fertility variation is there, or soil type variation is there, or for this means weed in some page weed is there or not there, we have to manage. Then second one is managing the variation, and then evaluation. After evaluation we are going to apply the things accordingly. Means after evaluation what we'll see, for which page of soil we have to require how much dose of fertilizer, or for particular page what type of insect is there, and which type of insecticide or pesticide spray we should go. This is the thing what we are doing in this precision farming. Here you can see the this is our precision farming, and this is what happening. We are following the flood irrigation and what regular practices we are doing, but in precision farming everything is based means it is connected by one means you can say by one computer we are operating the whole agriculture. Means every sensor and equipments are there, they are their calculation, their data is coming regularly to one computer. This thing you can say directly. This is the how means what is the component of precision farming. This is optimizing how we can reduce the inputs, then VRT, improved control, remote in this remote sensing means GIS, GPS will come, and then decision support system, management information system, database, and it will what increase the efficiency. How efficiency will increase? Less waste, improved gross margin, environmental impact, very less environmental impact. This is the all are the components of our precision farming. The means optimizing the everything. What we will do? Reduce the inputs. This all will come together for what? The precision farming. Yes, and this is what global positioning system. What GPS we are talking means you are all are from new generation. You know GPS. What is GPS? Then VRT. Just I told VRT component. This is variable rate technology or yield monitors, remote sensing, geographical information system. This is GIS. See there how we are going for this precision farming. This slide is very important for all of you. How we work in precision agriculture. First, what? Data processing. Yes. First, what type of data we are taking, according to that we will process. Then mapping. Yes, this mapping is very important, because by mapping we'll see where the how type of vegetation is there and what type of agriculture and what type of crop we should decide for that particular area. Then fertilizing, after deciding and after seeing that particular map, you can decide your fertilizer dose, how much it is required and what type means soil is there, what is the status of that soil fertility, and according to that you can go for your fertilizer dose, or you can decide the fertilizer dose for your particular farm. Then you will go for planting. Planting is also sensor based tractor advisor, means there will be one like sensor based advisor for your tractor, how to go for planting and which type of seed rate is required, and spacing, all it will decide. Then spraying, that is another important thing. For spraying means how much quantity it should be spread to that particular land and that particular page. It will be sensor based only. Scouting, that is another important thing what we are practicing in the precision agriculture. Then this harvesting, yes, this harvesting also sensor based, means what is the ground level when we'll go for a harvesting of a particular crop, means how much the distance should be there between this ground level and between our machine, or it is decide and it will control by the sensor where your equipment should be means have some approach to for resetting the your system. You can reset because sometime in our farm you can say up and down will come, and you can this machine will accordingly harvest the crop. And then again data, means when you will get the yield data, it is again will it will process. This is the precision farming system. Then we can say first you analyze, then plan, then apply, and then result. Again analyze, plan, apply, and result you can get. Then this is the what type of technology we are using in precision agriculture. These four is very important technologies what we are following in the precision farming or precision agriculture. First, that remote sensing. Then second is geographical information system. Then third one is differential global positioning system, DGPS. And then this VRT, yes, this variable rate applicator, means I will explain one by one. This first we'll see overview of this precision agriculture. Then after that I will explain each and everything about our sensor technology. Then precision agriculture in overview, how you can see this precision farming, means what is its advantage, what type of technology we are using, what result we will get, all it cover in this slide. Yield monitoring, how much yield you will get, and you can monitor the your yield, means what, and yield mapping, variable rate of fertilizer, means what type of fertilizer you should provide and which dose you will apply, all it will cover. Weed mapping, yes, it is very important what we are doing in precision agriculture. Weed mapping, after this weed mapping we can apply our weedicide according our field requirement, or according our means that particular weed, what type of weed is there, we can decide our weedicide dose and weedicide itself. Variable spraying, means definitely in some soil patches we have high density of this weed and insect, and in some patches we have less density of weed and this pest. According that we will go for spraying. Topographical boundaries, yes, it is there. Salinity mapping, yes, salinity mapping is very important for our irrigation purpose, for our fertilizer management, for all guidance system. It will guide to how your tractor, your harvesting machine. It will guide to all step and for each equipment what we are using. Record and data analysis. This is the overview. Then first we will have here remote sensing. Means first what is the remote sensing? It is the acquisition of information about an object from a distance with precision without coming into contact with the same. Means it will take a clear picture of from a distance. Means it will not come in the contact of that particular object, but it will draw a clear diagram or clear picture about that particular object. Remote sensing measure visible and invisible properties of a field or a group of field and convert point measurement into spatial information to monitor temporal dynamic plant and soil condition. Yes, it can measure visible and invisible property of your field, and it can decide the field condition. The more all thing will it cover this in if we'll go for aerial sensor. In case it can be either passive or else where sensor detect, reflect or imitate electromagnetic radiation from natural source such as sun. Active remote sensing, this in passive remote sensing what will happen, it will have it will take the electromagnetic radiation from natural sources such as sun. From sun also it will take the electromagnetic radiation, and it will draw its picture or diagram or map. Active remote sensing where sensor detect reflection response from object that are irradiate from artificially generated energy source such as radar. Means what it in this process we have to provide artificial energy in case of radiation like radar. The electromagnetic radiation EMR which is reflect or immediate from an object is usually medium to carry information in RS. However, any medium such as gravity or magnetic field can also be used in remote sensing. This picture you must see in how this our remote sensing is work. It is taking energy. It is taking energy from the sun also, and what type of energy means radiation we are giving, and means if you will say in yellow color, then this yellow color arrow is showing the radiation incoming from EMR, means in EMR, and what it is reflecting from ground, from trees, from buildings, from roads. It is going in red arrow, and then this blue one is emitted EMR. This EMR is again it is electromagnetic radiation only. This type of picture it can draw. Then geographical information system, GIS. Recently, use of GIS in agriculture has increased because misuse of resource like land, water. Because the farmers as well as contractor and everyone you having misuse of our natural resources like land, water. That's why this GIS means use of GIS in agriculture is increased. GIS is the principal technology used to integrate spatial data coming from various sources in a computer. Means what type of data is coming from various sources, it will come in one computer system. Yes. Then this is your geographical information system. GIS is tool which enhance decision making and planning process. What type of decision you are going to take and what if your planning should be. It will be a help in that. It is an collection of computer hardware, software, geographical data designed to efficiently capture, store, retrieve, update, manipulate, analyze, display all form of geographical reference information, help in integrating geographic data on various aspects such as soil, crop, and your weather, field, along with simultaneously model what type of model you are applying, provide a good platform for storage of base data, simple modeling, presentation of result, development of a user interface, and combination with GPS controlling navigation of farm. This is all about this GIS system. This is GIS system, how it works. Then DGPS, differential global positioning system. GPS come into picture in DGPS. Means your if it will come in one picture, then it will known as DGPS. The value of knowledge, a precise location within inches, is that location of soil sample and laboratory result can be compared to soil map. Means what type soil you are having from that particular soil sample, and for your laboratory report you can compare that same thing with your soil map. What type of soil map you are having, you can compare your result with that map, and you can decide your means which type of crop you want to grow there, and what should be your different dosage of your fertilizer and etc. Fertilizer and pesticide can be prescribed fit soil properties and soil condition. Means your fertilizer and pesticide dose and type you can decide according your soil property. Tillage adjustment can made as one find various condition across the field. Means what type tillage practices should be there. Means according your field condition you can go for that particular tillage practices. Means if your field condition is means you can decide your tillage means what type of instrument you should use. According that, one can monitor and record yield data as one goes across the field. Means across the field you can monitor your field, and accordingly you can draw your map, and you can decide your plan. This is the global positioning system. This is again one GPS, then data from satellite, data from, and then both are satellite, and how we are having in this is control station and receiver GPS control. The differential global positioning system means this is the clear cut that many satellites are there. It is connected to one base station, and then we are processing into computer or sense based technology what we are having. Use of DGPS. Yes, it is based on actually your GPS system, and it is means very important in this precision farming. DGPS because what it will do means what is the use of the DGPS. spreading means things, how to spread the things in the field or different locations. It will help in that. For spraying, that is very important, means how much quantity is required for different pesticide, insecticide, or your liquid fertilizer, and all it will decide, and how much it dose should be. It is sensor based. You need not to worry if once it will work, it will itself it will decide the dose. And then harvesting, then precision tractor guidance. Yes, it is. It will be guide for a tractor, means how it will work and how it will run, and how much quantity is required for that particular seed, for particular fertilizer, for means depth, how much we or that hero depth, and all it will decide by this tractor guide. Sampling, then it will can take sample as well. How here you can see this how we are going for spreading the things at different fields. And then this yes, this is very important in India also. You will see these things shortly, and we are practicing same things, but not that much with that much developed system, but we are practicing. This is the spraying system nowadays, and it is sensor based, means how much quantity is required. It will decide each and everything, and it will go for spray accordingly. Harvesting, yes, this is very important. If we will go with our system of means what we are following, but in that some crop losses is there, but in this system DGPS there will be no crop loss. It will be harvest crop means it will be harvest crop exactly, and very neatfulness. Precision tractor guidance, yes, it in field how it will work. It will guide to your tractor how much quantity is required, and all these things. It will be guide for your tractor. This is how we are taking the sampling. By this technology, we can take sample with high accuracy and with high effectiveness. Then last one is variable rate applicator, site specific application of material. Means on which site how much particular means particular thing should be applied. It will be site specific, and it will decide the particular site, and that it will work because it will save our resources. The variable rate applicator has three components. First, control computer, locator, and then accurator. This is not very clear, but okay, no problem. Means first is control computer, then locator, and then accurator. The control computer coordinate the field operation. It means this particular computer will control the field operation. It has a map desired activity and as a function of geographical location. It receives the equipment's current location from the locator, means it will receive the where your equipment is located in your field, means exact location of that particular equipment, which has GPS in it. In that particular GPS is there, and decide what to do based upon map in its memory data storage. It then issue the command to the accurator, which does the input application. Means after this processing, it will give command to accurator, and how much quantity is required. Accurately it will be supplied. Types of variable rate applicators. This is map-based variable rate applicator. This is one is a sensor-based variable rate applicator. see this picture. In this picture you will find many things. Means here everywhere the particular sensor is there. Means from your ground level it is first variable rate driver, then controller output. Means it will control the, then controller, then display or processor. It is just like our monitor, then DGPS antenna, then what type of data is getting from our computer, or it is a guide or a guidebook. Then in our computer that definitely will be code, and then mapped that is remote sensing technology what we are getting data from. It is based in this picture. All thing is clear. This type of agriculture we need to do. This is sensor-based variable weight applicator. It is sensor-based for spreading and for all these things. In you can say see the reflectance sensor, process control, gradient sensor, and then spreader. Chemical, how you can spray. This is another. The practical problem in Indian agriculture. Means in what we are facing in Indian agriculture, and what will be the problem if we will go for Indian agriculture. And if we want to apply this precision agriculture in our Indian system, then what type of problem we will face. Precision agriculture has been mostly confined to developed country regions of limitation of its implementation in developing countries like India. Means this precision farming system is made for this developed countries. Maximum it is means practicing in this developed country, but for developing country it is very new, and it will take time. But for developed country, because their land holding is means higher than our Indians land holding, and they have a good they have developed technology. No problem. We have also developed technology, but there are some integrated problems. Means we cannot come out from that problems. But then also we are trying to adopt this precision farming system for Indian agriculture, and many problems is associated with us because their land holding and their equipments, their means, economy and all these things, they have stronger than India. But we are trying, and definitely will do the things. Small land holding. First problem of developing countries like India is the small land holding. What type of precision farming? It means if your land area and your land area will be means if it will be high or it will be good enough to practice like precision farming, then only you can go for this precision farming. Otherwise, it is not possible for this small with this small land holdings. Heterogeneity of cropping system and market imperfectness. Means what type of market is there in our India, and what is heterogeneity. Means various or variation type is there in our Indian agriculture. Someone want to grow onion, other want to grow some other crop, and some want to grow wheat, and some other want to grow mustard. This a lot of variation is there. That's why our market also is not accordingly, and they are imperfect, we can say. Lack of technical expertise, knowledge and technology. Yes, this is very important. We are means in India we are spending only 0.3 of its agriculture gross domestic product in research and development. means only you can see here, and this is the our means very how to say, means only 0.3% means how we'll go for this agriculture research with this type of money requirement, and with this it will be 0.3%. And yes, this precision agriculture have another very, means another limitation is what it is very costly, means it is very costly method. It is in India we can practice regularly in this precision farming because it's sensor based technology. And as you know very well know these things, that it will go for this type of equipments, GIS, GPS, DGPS, and all these things. They are very costly, and it will be not affordable by our farmers and for our scientists also. That's why, yes, there is one chance if we will go for this community farming, then only it is possible. For whole area, we can name the things and we can practice, but it will take time because a lot of diversity is there in our cropping system, and in all these things we have very much diversity. That's why it will take time. Present scenario precision farming, what type of we are practicing in our India. Means it is a present scenario for our India, what I'm talking about. Space Application Center, ISRO, in collaboration with CPRI, Central Potato Research Institute, Shimla, has initiated a study on exploring the role of remote sensing for precision farming. Our Potato Research Institute is applying this remote sensing procedure for our farming system or for precision farming. It is very, means innovative what they are doing. Then Space Application Center, ISRO Ahmedabad has started experiment in the Central Potato Research Station farm at Jalandhar, Punjab, to study the role of remote sensing mapping and the variability with respect of space and time. Yes, and that Ahmedabad also we are started that remote sensing process for the this Central Potato Research Institute or station. This is again PDFSR modem. This is a project development farming system research at Modimpuram and Merit UP. Collaboration with the CIE Bhopal also initiated variable rate input application in different cropping system. At there also we are practicing the things. And this is my conclusion, how I can conclude this precision farming. Then precision farming technology can help in managing the variability within the field. Means if you will see in particular field also a lot of variability is there, and then precision farming technology can manage that variability in efficient way. Means if you are from some farmer family, then definitely you know the things in one farm only how much variability are getting on some soil page, that crop is growing very nicely, but another page their germination also is not there. This type of variation we can manage by this precision farming. This technology help in resource conservation by actually what is need rather than uniform application of inputs. Yes, what this technology, what we can do with this technology, means for a particular soil type or for particular field, how much quantity is required for fertilizer, for insecticide, we can decide by this. But by regular means the uniform application of input we'll go for wasting our money, or we are destroying our nature and all these things. So that's is very important. So we by this technology we can decide the exact and with accuracy the dose of that particular things, how to apply that method also will be there. Now I think, Tamanna, it is from my side, and now if you have any doubt, then please ask to me.
Thank you for giving us, in brief, the overview of precision farming, sir. With passion and dedication, a plant breeder can also be a precision farming expert, is what you taught us today. So over to you, candidates. If you have any kind of queries, please raise your hand. Participants, any queries, you can please raise your hand or put up your queries in the chat box. The session is open for discussion. Please effectively utilize and represent yourself. So, sir, question from Sumant Bola. The question is, sir, can you please elaborate scouting?
What?
Dr. Please, sir, can you please elaborate what is scouting?
Actually, Tamanna, your voice is not audible to me. Please repeat.
So there is one question.
Yes, please.
So there is one question from Sumant Bobala. Can you please elaborate what does scouting refers to?
Scouting, yes, definitely.
The word scouting.
Yes, definitely. I will. This is nothing. This scouting is nothing. It is the exploring the information, means what type of information we are having. This is the what we are having the information. According that, we will go for that particular.
Okay. So this was the first question. So hope you are clear, Sumant. If you have any other doubts, you can ask. So, sir, the second question from Saumyajit Tripathi is, how precision farming can be applied in coastal saline region?
Yes, this is actually very nice question, because in that particular area only we have pre-planned for this farming system. For this where this landsliding problem is there, definitely it will means by your what type of picture by you are taking from your remote sensing technology. Definitely, it will clear how much it is your soil, and how this soil condition is there. Means what type of vegetation is there. According that, it will decide, means what means what it is future of your land, or what will happen in the future. According that, means you should go for this. Regular agriculture cropping system, means for a crop like rice, wheat, or you should go for this plantation. It will decide, means what type of crop it should be there in your field. It can be decided by that particular images what we are taking for that by remote sensing technology. And you can decide once if you will decide your crop, then it will work on that particular land or that particular area.
Sure. Thank you, sir. So let us move on. So, sir, there is one more question.
Yes, sir.
From Abhishek Singh.
Yes.
Can you explain that how smart breeding or marker assisted breeding aligns with the principle of precision farming?
Yes, Abhishek, it is actually, I think you are from genetics and plant breeding. That's why you are asking this question. Yes, now what we are doing in plant breeding, regularly we are going for the regular plant breeding system. But what we are talking in precision farming means everything is decided, means first we will decide, then only we will go in the field. Means if you are having a particular means crop type, means what crop type it should be there in that field, and what means you by using molecular markers, what is the requirement of that particular area, you can incorporate that particular gene to your crop. Means that community want to practice same crop at that their field, they do not want to change crop, then you can change the habit of that particular crop by incorporating gene from wild sources and from other sources. uh, According that you can manipulate, means some type, means if we'll go precision farming somewhere, then that cold is there, but that our crop is sensitive to particular means low temperature, then we will go for the cold resistant gene, and we can by taking help of molecular markers and smart breeding, we can manipulate our crop according to our requirement. Definitely it will work, but it is very new for us.
Okay. Thank you, sir. So the next question is from Sunita Sagwal. So the question is role of genetics and plant breeding in achieving the precision farming goal.
Yes, same thing. I think it is very related to last question only, and I am already explained. Then again, I will explain. For plant breeding, actually, what if you know which who is asking, I'm just sharing these things. If you know, the plant breeder have always extra responsibility. Then if it is precision farming is completely agronomical based, but they have to take help of plant breeder. Without plant breeder they cannot do things. Yes sir, we are want to grow this crop in that particular area, but it is not means we are not able to grow that particular crop in that particular area. That's why what type changes you can made by your breeding system or by your molecular marker system, then according that their demand, we will go for our breeding system, and means what type of crop they are need with some little bit changes, because only plant breeder or a biotechnologist only change the genetic background of a particular crop. So again I have explained.
Exactly. Thank you, sir. So the next question from Ankita Tiwari is, how can we use precision farming technology to reduce the incidence of disease in a particular area?
Yes, actually, this is also another very nice question. In yes, what in our past we faced that completely loss or partially loss of particular crop, completely or partially loss of complete that particular area, and it is means if you remember nearly 2019 or 2020 in South India, that some one insect came, some stem borer, another means species came, and they destroy the completely in that area, that maize field. This situation is very related to that condition or that situation. If it is there, then what you are doing with your remote sensing, and what you are doing with that your precision farming, you have each and every data of your field, means which type of disease will be there, which type of insect are already present in there, which type of population is there. But if by mistake if it is your seed borne disease, then also you will get because it is a sensor based technology, you cannot go directly in that field. You will just have some type of pest of your seed, means this seed is not infected with seed borne disease, and like that. It means every step you there is check is there. Okay, you did mistake in your this to knowing the seed health, then again you are having, means when you are going for that means in early stage when that disease will come, before that you can have a spray for that particular fungicide or for particular chemical to that particular crop. Means on many steps you can control that particular disease. And I think that there will be not a severe effect on that particular area. You can control in patches, means if that disease come in particular patch, you can destroy whole that patch, so it will not spread in another area of that particular field or that particular region. This can we can do, means severe effect will be not there. I just think like that in precision agriculture, because it is sensor based technology. What we are doing in regular agriculture, we are just seeing that disease action is not there, but in precision farming, you first you will go for the your seed health, and all is that based on technology report. And I think it is clear to that particular participant.
Yes. Thank you, sir. So the next doubt is from Anil Dhiman. Is precision farming and sustainable agriculture the same?
Just I was expecting this question should be there, because and no, this sustainable agriculture is not completely, but it is different from precision farming, because here what we are using, that technology we are not following is sustainable agriculture. But yes, the motto for both is to reduce the input and to increase the output and to save the nature. Means objective may be same, and it is same, means our objective is same. We will not destroy the nature, we have no pollution and no pollution effect on our environment and our soil and our nature, and will not affect anyone, means animals and human health. And sustainable agriculture also we are doing the same thing, but in sustainable agriculture what we are doing there, there is limitation of this use of chemicals and all these things. But in precision farming we are having that all these things, but at a limited use, not in that regular agriculture, means very limited use. But in sustainable agriculture also we are doing, but no, there is very less scope for these things. Means objective is same for both, I can say objective is same for both.
Yes, very well answered, sir. Thank you. So the next question is from Abhishek Singh. Can we consider the phytotron technology as the precision farming?
Drone technology, what is asking?
I repeat, can we consider the phytotron technology as the precision farming?
Phytotron technology can be means maybe part of this precision farming.
Achha.
Yes.
So, sir, the next question is from Himanshi Saraswat. As it is a high initial cost based technology, so how to gain benefit of this in growing agricultural startups? And is there any substitute for the cost reduction? It's all about economics, sir.
Yes, definitely. This question is I'm expecting. Yes, it is very costly. In my presentation, I think 5 to 10 times I've said this is costly technology and precision farming. Yes, there is chance to reduce the cost of this precision farming. What we can do if we are means it is it will be if it will be a community approach means in particular area means we are adopting one village, then the farmer unity should be there, and all farmer involvement should be there, and we can means we can have a station for this precision farming and to control the things, and for same equipment it can be used for hundred of farmers, and for that particular area we have one or two this developed system, and we can use for that number of farmers in at some gap of time, then it will be adopted, it can be adopted by that means if we'll go for community approach, then yes we can adopt the things, but for individual farming farmer in India, it is not, I think it is not possible. How much he is having this economic strength, then also it is not possible. Yes, if a government is aware and some subsidy will available, then he can go. But for community approach, definitely, then there also be government involvement should be there. I think so.
Okay, moving on to next question. So from Dr. Raman Singh, precision farming is new concept, but technology in India is not that much up to date as it is possible to make it success in India.
Yes, Dr. Ramanujan, what you are asking is exactly we are in that condition because now we are only in developing condition. But if we, I think you just go for yesterday in the 623 what we get means what now India got the speed in developing technology. It is the world can see. Yes, we have limited resources. Money problem is there with me or with our scientist community, but the technology means knowledge of technology and knowledge of science, we are not in means lagging phase, we are in lagging phase in knowledge. Yes, definitely, but now in the present scenario, yes, we need to go for new technology, and to develop technology we require much fund. Just that's why only I'm talking this 0.3% contribution for this agriculture development. It is should be increased. Then our scientists will definitely will develop technology. I have means I have confidence on our agriculture scientist community. If government support us and government will provide fund, then we can develop anything and any technology. And that yesterday, what happened, this Chandrayaan 3, it is giving boost to our scientist community for every sector. So we now in present we are not able, but in future definitely we will do the things with technology. Technology will be not problem. I think we can develop technology, but that problem with will be the our farmer land holding and this yes economy. Yes, definitely it will be some problem are there. We are not in that stage to adopt this precision farming. Okay, I agree, but we cannot develop the technology. I'm not agree with that. We can develop the technology, but yes, what we will do if we develop technology if the use is not there? We are waiting for that. But we are means we are in that position that we can develop the technology.
Yes, sir. Thank you. Next, moving on to the next question. The question is, land holding is a major challenge for precision farming in India. So how can we make this practically possible in India?
Yes, I just from second last question, I just explained these things. No, we should go for community approach. Means
Yes.
completely we cannot go for precision agriculture, but partially we should start, and after that we can adopt completely. Means if you know what happened with this Sri Lanka, this they all go for sustainable agriculture without knowledge of sustainable agriculture and their means production. We cannot go directly, but partially we can adopt in particular area. Means community based approach should be there, and the technology what we are following, we involve one by one. First we will go for remote sensing, then we will involve this DGPS system and all these things, but not all at a time. Approach, and government role should be there for that also. If some type of means loss is there, then government should be means this uh, insurance should be there for that particular crop or that for particular area. I need to do that, because we are at least we are means we are trying to adopt that system. Means government should be there behind that particular farmer community. This is my submission.
Fine. So the next question is from Shani Gulaya. So she's from JNKVB University, pursuing PhD research scholar. Sir, I want to know, precision farming is suitable for small and marginal farmers, or if it's not for small and marginal farmers, how can we provide such technology for such farmers? And which type of technology can we provide for such type of farmers? She's asking for small and marginal type of farmers. What could be the best provided from
this yes, land holding what that in problem with precision agriculture, I said one thing, this land holding and small land holding and marginal land holding is the problem of India. Then also we can go, but means with some technology, means again it will come for community approach, but that particular farmer, it is not possible to adopt that precision agriculture. Means precision farming, he cannot adopt. But if they will go for community approach, and then it some level they can adopt, at some level they can adopt. But again means there should be a community approach, but small and marginal landholders, they cannot adopt the technology because the price and the cost of that equipment is very high. But as a scientist, I should not say like this. We are trying to do things in that manner. Means when our government will involve, then only it will be come to truth in India.
Yes, sir. Moving on to the next question. So the next question is from Dr. Alokman. Very nice presentation, Dr. Ashok. I have small doubt about the precision farming. That is any alternative to precision farming which is difficult in India due to small land holding?
Yes, this can be means alternate is what is the alternate? I think this is a complete developed model. If according Indian situation, we want to go for this precision agriculture, then if you see this IFS model in India, integrated farming system model in India, like that alternate we can find, and means better use of our input and maximum output we should get. Means but that IFS model is based on our regular agriculture practices. But if we made that like these models with this present technology, then definitely something will come. Means at some level we can adopt from our precision farming, and some level from like IFS model, and when we'll compile the things, and then definitely for Indian condition we can develop the model. This can be done. This can be definitely done. with this our Indian agriculture.
Yes, fine. So, sir, then moving on to next question. So, what about the export percentage? This is the question from Suraya. In what terms she's asked? What about the
Export
percentage?
export position.
Export percentage.
Oh, expert percentage. Yes, expert percentage is now in this area. We are not that much got expertised, but for I just want to say one thing. If you want to become expert in one thing, then there should be a regular project should be there. If you want to expert in one particular thing, means regular funding and regular project should be there. You should not face any problem with funding and like that. Means our Indian system, we have very less means expertise system for this precision farming or with precision agriculture, because it have role of this our means like space scientist and this that's why we are not able to do the things, and that percentage is means very low. I will say very low in this our in India. But if you talk about the foreign countries, means developed countries like America, and they are following the things because they have no fund problem actually. That's why the percentage is high there. Percentage is higher there.
Okay. So the next question is there any low-cost indigenous technology in context of precision farming for small and marginal farmers?
I think Tamanna, I explained this question already.
Exactly.
And
So then we'll move on to the next question from Kapil Verma, who's from
yes.
New Delhi, IIRI New Delhi. So, sir, his question is nano urea will be useful in achieving the target precision farming, as it is contradictory topic nowadays?
Yes, this nano urea, this contradictory topic in our India, because what they are telling, and that result, actual result is not coming in the farmer field. But that nano urea definitely, because it is sensor based technology, definitely nano urea will work with precision agriculture. I have that confidence, because what how that nano urea is developed, that is the nearly similar process what we are following in this precision agriculture. And definitely, if a needful application we will give to our field, then definitely it will work, because nano urea is very recent one, and what is happening, what how much quantity should be there, it is not decided. Means in particular page what type of quantity or dose you have to provide, that is not decided by they are going uniformly. But in precision agriculture, it is decided how much quantity of nitrogen you should provide. Then in that case, definitely that nano urea will work, and any other nano fertilizers.
Okay. So moving on to next question from Shani Gulaya. So what type of technology we can provide marginal sources? It is the same question, marginal farmers and small farmers again. So the next question is precision agriculture also known as satellite farming, and what are IoT sensors used in precision agriculture?
I want to say one thing. What type of this aerial sensor are there? We are using aerial sensor in that particular agriculture, means this precision farming, and it is based on that particular, means the technology, means what type of sensor is required, that for particular condition we are having that particular sensor. Means if we'll go for spray, then for according to that requirement only that sensor is used. But exact that sensor type of sensor I think I cannot explain that one because that is separate technology what they are doing with that. That is very means. I think that that is not possible to explain for me. What type of sensor it is there in inside? You cannot work with that. That is not in my knowledge. Sorry for that question.
Yes. The next question. So this is all about the question and answer session. So any other questions? Any other queries, candidates? The session is open for discussion. If you have any kind of queries, you can please ask. It was indeed a wonderful session today. There was a huge interaction from student side, and the presentation was also indeed very well done. Thank you, sir. Thank you so much. Any other questions, students?
Thank you, sir, for the excellent presentation. Your clear explanation presented much like animations made it easy to grasp the concept. I really appreciate it. Thank you.
Thank you so much. Thank you to Tamanna, Sunil, Kunal, and everyone who is means have relevance with the Sohos society. Which guys, what you are doing, it is very wonderful job. You are means the choosing the topic itself is a task, and you have chosen this precision agriculture. It is very innovative, and what you are doing it is good job because at a minimum price you are giving maximum knowledge to students, and you have training of 7 days for the same topic. It is wonderful job, and thank you very much for selecting me or for inviting me for this particular lecture on this online training program. And especially thank to my younger brother Kunal Narwal. He invited me and he said the thing, and whole team, SOS team, and congratulations to everyone, and thank you so much for being part for this particular training.
Where on the other hand, India is proud with the successful launch of Chandrayaan-3.
Yes,
you
yes.
hear the young generations pertaining a lot relating to GIS and precision farming that goes beyond agriculture. So let us see if we can plant and contribute something in the moon in the days to come. Thank you, sir. So
Yes,
my heartfelt thanks goes out to Dr. Ashok Kumar for letting us know the collective endeavor of precision farming that transcends the geographical boundaries. And your presentation was indeed very appealing, and you got us to know a lot through the visuals of your PPT. So thanks again, sir. Thank you so much.
Thank you, sir.
Okay.
So thank you to all the participants. You have collectively participated today and have presented yourself very nicely today. So wishing for this in the coming days also. And in the spirit of collaboration and exploration, let us engage in the meaningful conversations, forge the new connections, and leave here with a renewed sense of purpose and enthusiasm to continue our scientific endeavors in the coming days. Thank you, one and all.